Yes, it is 11:11. We will start now. So this is the chapter number 12. Today we are going to start, that is aldehyde, ketones and carboxylic acids. It is having 8 marks weightage. It is one of the most important chapter in organic chemistry. It is having the biggest weightage of marks, 8 marks. Marks are actually 6, but with option it is having 8 marks. Out of 98 it is having 8 marks, and out of 70 it is having 6 marks. So before this chapter, I want to give information to you, because some students are remain absent. I saw the previous attendance. So sometimes the students are present 46, sometimes the students are attending the lecture 56. Many students are absent. So that's why I put one important note on WhatsApp also. Whatever the important questions, whatever the questions asked for JEE, NEET, CET, and whatever the syllabus deleted, then non-evaluative syllabus for this year due to COVID-19, it will, all the points will be discussed in the lectures. No any special PPT or no any special Word PDF file will be shared to you as per the instruction given by the principal sir. So I request all the students, please attend all the lectures and complete the assignment, whatever the assignment which is given in the slides, and also the homeworks. On the same day before 12 p.m. we have to complete it. Means at night 12 o'clock we have to complete the assignment work, and we have to mail to me. So 27 students are joined now out of 73. Many students are not joined here. So we will start the chapter aldehydes, ketones and carboxylic acids. All these aldehydes, ketones and carboxylic acids, these are the functional groups. In 11th standard, we know these words. So these are the some questions asked for previous board exam. Already this PPT is shared to you. After finishing the chapter, we have to solve all these questions. All these questions are asked for previous board exams. Note this. So the introduction part, I will within 2 minutes I will introduce what is meant by this carbonyl compounds. Aldehydes, ketones, carboxylic acids, these are the carbonyl compounds. Carbonyl means they contain CO bond. This CO bond is called as carbonyl bond. So aldehyde, ketones and carboxylic acids, esters, all these contains carbonyl bonds. This is a carbonyl oxygen and this is carbonyl carbon. And directly I will show some examples here. See, some examples are there. Yes. So this is aldehyde in which the carbonyl carbon is attached to the R group and H. This is a functional group of aldehyde, is COH. I will explain the difference between aldehydes and ketones. The main difference is carbonyl carbon is attached to one hydrogen, and in case of ketones, there is only CO group. This CO may be bonded to the R groups. The R groups may be same or different, or it may be attached to the AR group, means aromatic groups may be attached. So the main difference between aldehydes and ketones is it is the CHO group, COH, means one hydrogen is compulsory attached to this CO group, but in case of ketones, no any hydrogen is attached. Both the groups are R groups, or both the groups may be AR groups. In case of carboxylic acid, C, one OH group is bonded to the carbonyl. So the functional group of carboxylic acid is COOH. Remember this COOH. Then in case of this acid anhydride and amides, esters, these are not the part of this chapter, but all these are carbonyl compounds I have shown here. Carbonyl compounds means the compounds which contain this CO group, remember. So I'm coming to the definition of aldehydes. As we know in the chapter alcohols, phenols and carboxylic acids, I explained there. Aldehydes are the first oxidation products of primary alcohols. Yes, aldehydes are the first oxidation products of primary alcohols. Means when the primary alcohols are oxidized, we get the product aldehydes. And ketones are the first oxidation product of secondary alcohols. The keto or oxo group, the carbonyl group is also called as keto or oxo in ketones, remember. The keto or oxo group is not located at the terminal carbon. It may be incorporated in between. But remember one thing, in case of aldehydes, the aldehydic group means this COH group is always situated at the terminal carbon. Terminal carbon means COH, it will be situated at the last carbon or first carbon. It is called as terminal carbon. Then I am coming to the classification of aldehydes directly. Aldehydes are classified as aliphatic and aromatic aldehydes. You know the terms aliphatic and aromatic. In 11th standard, we already learned these terms, aliphatic and aromatic. In case of aromatic compounds, they contains benzene ring, and in case of aliphatic, they do not contain benzene ring. So I am coming to first aliphatic aldehydes. The name itself suggests, in case of aliphatic aldehydes, the CHO group is attached to the R group. And in case of aromatic aldehydes, the CHO group is attached to the benzene ring. So this is the main difference between aliphatic aldehydes and aromatic aldehydes. In case of aliphatic aldehydes, the CHO group is attached to the aromatic aliphatic we can component, and in case of aromatic aldehydes, the CHO group is attached to the benzene ring. This is the main difference, but the exception is formaldehyde here. The formula of formaldehyde is HCHO. In this HCHO, in this the carbonyl CHO group is attached to the hydrogen. Though it is attached to the hydrogen, it is considered as a aliphatic aldehyde, remember. So formaldehyde is exception to the aliphatic aldehydes. Now I am coming to the aromatic aldehydes. So aromatic aldehydes, in which the CHO group, see clearly here, CHO group, this CHO group is directly attached to the aromatic ring. These are called as aromatic aldehydes. So this is a benzene ring and this is a CHO group. So this is a benzaldehyde, this is salicylaldehyde. Salicylaldehyde, it is prepared in aldehydes ketones in the Remer-Timmer reaction. See, salicylaldehyde means OH group is there at ortho position, and in case of this para-nitrobenzaldehyde, this nitro is situated at para position, which is 1,4 position. This CHO is number 1, this is number 2, this is number 3, and this is number 4. So this is para-nitrobenzaldehyde. All these examples are the examples of aromatic aldehydes. Then I am coming to the classification of ketones. Same as aldehydes, the ketones are classified as aromatic ketones and aliphatic ketones. The definition is same. In case of aliphatic ketones, the CO carbonyl group is attached to the R group. And in case of aromatic ketones, this CO group is attached to the aromatic ring or AR group. The AR group may be same or AR group may be different. In case of aliphatic ketones, the CO group is attached to the R group. R may be same or R may be different. So depending Depending upon the nature of R groups, again the aliphatic ketones are classified as simple ketones and mixed ketones. In case of simple ketones, say simple ketones are also called as symmetrical ketones. Both the R groups are same. When both the R groups attached to the carbonyl carbon are same, it is called as simple ketones, or it is also called as symmetrical ketones. Symmetrical and simple. This is as for board exam. Remember, note that this classification is asked for 2 times for board exam. Simple or unsymmetrical ketones and mixed or unsymmetrical ketones. The question was asked like this: explain the classification of ketones, 2 marks. So only we have to write these simple symmetrical ketones. For half mark, we have to write the definition, half mark for the example, again half mark for the definition of unsymmetrical ketones, and half mark for the example. One example is expected. So this is a dimethyl ketone. It is also called as acetone. This is the common name. Now, next one is mixed or unsymmetrical ketones. See, the groups attached to the carbonyl group is one is CH3 and one is C2H5. So both the when groups attached to the carbonyl is different, this is called as mixed or unsymmetrical ketones. In this also, see the groups attached to the carbonyl, one is C2H5 and one is propyl group. This is CH2, CH2, CH3. The name is ethyl propyl ketone, and this is ethyl methyl ketone. These are the common names. We will discuss the common names and IUPAC names in the next slides. So remember, these are the classification of ketones on the basis of R groups. Now, aromatic ketones. As the name itself suggests, aromatic ketones are the ketones in which CO group is attached to the aromatic ring. See, both the groups are benzene rings. The name is benzophenone, or the common name is diphenyl ketone. In this another example also you can see the CO8 may be attached to the one is R group, or one is AR group, and one is R group. So aromatic ketones, one important condition is the CO should be attached to the benzene ring, and another group may be R. It is accepted. Only one group should be aromatic. So this is the main condition for the aromatic ketones. Then the next one, you must know this. This is not asked for exam, but you should know for the JE and NEET exam. For the CET, this questions may be asked for board exam. No any question will be asked for board exam for this year due to COVID-19. But for the CET purpose, NEET purpose, JE purpose, this is very important. So you can read at your home. This is very easy. Within 1 minute, I will explain. Aldehyde ketones are responsible for many flavors and odors that you will readily recognize. See, the benzaldehyde having the bitter almond flavor, vanillin, which is having the vanilla flavor, which is used in ice creams and cakes. Then cinnamon aldehyde, which is having the cinnamon flavor. So this is the camphor. You know the flavor of camphor. So no any question will be asked for board exam for this year. But for the CET, JE, NEET purpose, this is important. Then next one, classification of carboxylic acids. We already discussed the classification of aldehydes, then the classification of ketones, simple ketones, then mixed ketones, aliphatic ketones, aromatic ketones. Like this, carboxylic acids are also classified as aliphatic and aromatic carboxylic acids. The conditions are same. When the COOH, this is the functional group of carboxylic acid, when it is attached to the aliphatic system, means R, then it is called as aliphatic. And when the COH group is attached to the aromatic system, then it is called as aromatic carboxylic acids. We will see some examples. See, this is example of acetic acid. Acetic acid, the IUPAC name is ethanoic acid, because there are 2 carbons. The COH group is attached to the CH3. So this is a aliphatic carboxylic acid. Propenoic acid. The name is propenoic because there are 3 carbons, 1, 2, 3. Later I will discuss the nomenclature. Only remember here one thing. This COH group is attached to the R aliphatic system. Then depending upon the number of COH groups present, the carboxylic acids are classified as mono carboxylic acids, dicarboxylic acid, tricarboxylic acid, and so on. So in this example, see one COH group is attached. So it is called as monocarboxylic acids. Then this is a dicarboxylic acid, oxalic acid. See, 2 COH groups are there. And this is tricarboxylic acid, citric acid, which is present in lemon, which is present in orange. 3 carboxylic acids are, 3 COH groups are there. So it is an example of tricarboxylic acid. So this is the classification of carboxylic acid. Exception is formic acid, remember again. Like formaldehyde, HCOOH group. In this, COH group is bonded to the hydrogen, though it is not bonded to the carbon, any carbon. It is under the heading aliphatic carboxylic acids. Then aromatic carboxylic acids, as the name itself suggests, aromatic carboxylic acids, the COH groups are directly attached to the benzene ring. This is a phthalic acid in which 2 COH groups are bonded to the benzene ring. Benzoic acid, this is a very good example of aromatic carboxylic acid. We also studied in chapter number 15, 11th standard, aromatic compounds, COH group. The name of the chapter was hydrocarbons. In that hydrocarbons, these examples are already learned. Then this is aspirin, acetyl. This is also prepared in chapter number alcohols, phenols and ethers, chapter number 11. You know, this aspirin is a very nice drug, which is an antipyretic and analgesics, in which acetyl group is there, OCOCH3, and one is COH. So this is also the example of carboxylic acid. Then when the aromatic compounds in which COH group is not directly attached to the benzene ring. See in this example, the COH group is not directly attached to the benzene ring, but it is attached to the CH2, and this CH2 is attached to the benzene ring. So such type of carboxylic acids are called as side chain aromatic acids or side chain carboxylic acids. So the additional information I will share: carboxylic acids are widely distributed in nature. They can found in plants and animals also. L-lactic acid, it is present in curd. Then citric acid is found in citrus fruit, lemons. Acetic acid is a key ingredient of vinegar. This may be asked for MCQ, for JE, NEET, and also CET. Then I am coming to the nomenclature system of aldehydes and ketones and carboxylic acids. For the nomenclature system, the rules are same. Select the longest chain containing the carbonyl compound, that is aldehyde, that may be ketone, or that may be carboxylic acid. But the main thing I will explain, the common thing, the common names are different and the IUPAC names are different. The names of aldehydes and carboxylic acids are related to each other. First, I will explain the common names. See, formaldehyde, it is derived from the formic acid. The formic acid and the formaldehyde. See, this is formic acid and this is formaldehyde. Chaitanya, close your video. Yes, then acetaldehyde, it is derived from the acetic acid. Propanoaldehyde, it is derived from the propanic acid. Mean the names of aldehydes are derived from the names of carboxylic acids. This is the HCOH is formic acid, and see the aldehyde is formaldehyde. Then acetic acid, the aldehyde is acetaldehyde. Then propanoic acid, the name of the aldehyde is propanaldehyde. These are the common names we will discuss in detail. I will show one chart to you. When substituted carboxylic acids are there or substituted aldehydes are there, see the carbon number is denoted with alpha, beta, and gamma. The carbonyl carbon, say Nearer to this carbonyl, carbon number 1 is alpha, then next one is beta, next one is gamma, then delta, like so on. So to the beta carbon here, see bromine is attached. So the name is beta bromo butyraldehyde. Why it is beta? Because to the beta carbon, bromine is attached. That's why it is beta bromo and butyraldehyde. Why it is butyraldehyde? Because there are 4 carbons. 1, 2, 3, 4. 4 carbons are there. That's why it is butyraldehyde. When 3 carbons are there, it is propanaldehyde. Like this. So you must know these things. This is not asked for board exam. This is additional information which will not ask for board exam. This is deleted for this year only. You must know this series of straight chain dicarboxylic acids. You can read at your home. No any question will be asked for it. Then I am coming to the IUPAC names of aldehydes and carboxylic acids. Directly I am coming to the chart. Then you will easily understand what is the common names, IUPAC names. See, the name of the aldehydes are methanol. When there is only one carbon, these names are derived from alkanes. Methane, one carbon. If one carbon is there, it is methane. And when one carbon is there, the aldehydes are called as methanol. The aldehydes are called as methanol. Then when the 2 carbons are there, it is ethanol, propanol, butanol, pentanol, hexanol, like this. As the number of carbons are increasing, the names will be changed. So when there is only one carbon, the name is methanol. The 2 carbons are ethanol, propanol, butanol, pentanol, hexanol, like this. Now coming to the carboxylic acids, the name of the carboxylic acids and aldehydes are relatively same. When one carbon is there, the name is methanoic acid. It is methanol, it is methanoic acid. Ethanol, it is ethanoic acid. It is propanol, it is propanoic acid. Then butanoic acid, it is butanol. Aldehydes ends with Al, remember. All the aldehydes ends with Al and all the carboxylic acids ends with OIC. Methanoic, ethanoic, propanoic, then this is when the straight chain is there, it is called as butanoic acid. When the substituent is attached, it is 2-methyl propanoic acid because on the second carbon methyl group is attached. If the CH2 double bonded means alkene is present, see the name is propene 2-in. In substituent we have to attach there, prop 2-in oic acid. Say, this is carbon number 1, this is carbon number 2. The COH carbon is 1, this is carbon number 2, and this is carbon number 3. What is the name? Prop 2-in oic acid. This 2 indicates on the second carbon double bond is there. So prop 2-in OIC because functional group is acid is there. And see the in case of aldehydes, what is the name of this aldehyde is prop 2-in Al. Means on the second carbon double bond is there. Prop indicates 3 carbons, 2 indicates on the second position is En is there. En means double bond. Al, why this is Al? Because aldehyde, the compound is aldehyde. So the name is prop 2-in Al. Remember one thing, on this chapter, one IUPAC name will be asked. So make a note there for the chapter aldehydes, ketones and carboxylic acid. 1 mark is always reserved for the IUPAC nomenclature system. They may be asked, they may ask the structure or they may ask the nomenclature. Means the structure will be given or we have to write the name, or the name will be given, we have to write the structure. So you can go through the chart at your home because it is not possible to discuss all the IUPAC names and common names here. You can read at your home, and if any doubt is there, you can ask me, I will explain. One important thing, COH group is there. If the aldehyde group is there attached to the alicyclic system, it is called as carbaldehyde, CA. One important thing I want to explain, only this, if CHO group is attached to the alicyclic, it is not aromatic, alicyclic system, if it is attached, it is called as carbaldehyde. So the name is cyclohexane carbaldehyde. This ring is cyclohexane and the group attached is formyl group. So we have to name like this: cyclohexane carbaldehyde. And in case of carboxylic acid, what is the name? C, cyclohexane carboxylic acid. So the name carbaldehyde is only given for the aldehydes. For which aldehydes? When the aldehydic group, CHO group, is attached to the alicyclic system. Alicyclic means, in English standard, we already know cyclopentane, cyclohexane, then the cyclopropane. This is called as alicyclic system. So the names are called as carbaldehyde. Now I am directly coming to the IUPAC names of ketones. Say, it is very easy to understand the common names and IUPAC names with the help of the chart. See here, 1, 2, 3 carbons are there. So the name is propanone. Ketones always ends with word ONE. Aldehydes ends with AL. Carboxylic acids ends with OIC, and the ketones ends with ONE. Again, the nomenclature system is same. First, I will explain the IUPAC nomenclature system. 1, 2, 3. 3 carbons are there. That's why the name is propanone. Then this is butanone, because there are 4 carbons are there. 1, 2, 3, 4. Also, the position of the CO group is important. This is the 2-butanone. 2-butanone. This is the 2-butanone. 1, 2, 3, 4. Now, I want to ask one question: 3-butanone is possible or not? We have to draw the structure of 3-butanone and tell me 3-butanone is possible or not. Then I'm coming to the next one. This is pentane 2-one. See here, for the pentane 2-one, this is a 2 number is written because the second number indicates the position of the carbonyl. 1, 2, 3, 4, 5. Total 5 carbons are there. On the second carbon, CO group is attached. So this is the pentane 2-one. This is the pentane 3-one, because the CO is on the third carbon from this side or this side. We can start the numbering because from both the sides the numberings are same. We have to start the numbering from that side. CO should get the minimum number. This is IUPAC nomenclature system rule. The CO should get the lowest number. So that's why we have to start the numbering from 1, 2, 3, 4, 5 this side. But in the fourth example, we can start the numbering from right hand side or left hand side. We get the same name, pentane 3-one. Then I'm coming to the next example. One compound is given here. 1, 2, 3, 4, 5, 6. 6 carbons are there. And the CO group is there on the third carbon. See, 1, 2, 3. So what is the name? IUPAC name 2-bromohexane 3-one. On the second carbon here, bromine group is there. That's why the name is 2-bromo. 2-bromohexane. Why it is hexane? Because total 6 carbons are there and ends with ONE. And 3 indicates on the third carbon, carbonyl group is there. 1, 2, 3. See the carbon number 3, CO group is there. So the name is 2-bromohexane 3-one. So make a practice at your home to write the name of the aldehydes, ketones, and carboxylic acids. I will take one example of this aromatic system. This is a benzophenone, and the common name is a diphenyl ketone. Also, the common name is also same, and IUPAC name is also same. Common name is accepted by the IUPAC in case of benzophenone. See, this is a very good example, acetophenone. IUPAC name is acetophenone. You can write the common name like methyl phenyl ketone, alphabetically which group came first. We have to write methyl phenyl ketone. This is a common name. This is a 2-chloro-4-methyl. 10 minutes are remaining. Yes, this is a 2-chloro-4-methyl cyclohexanone. See, in the example 11, no any substituent is attached, only the line is there. So this line indicates CH3 group is there. Remember, if the line is there, always it means CH3 group is there. So what is the name? 2-chloro-4-methyl cyclohexanone. At the second position, chlorine is there. So this carbonyl is considered as number 1. The second one is chlorine, and the fourth, at the fourth position, methyl group is there. So the name is 2-chloro-4-methyl cyclohexanone. Cyclohexanone. Why it is cyclohexanone? Because the ring is cyclohexane ring, and the name is 2-chloro-4-methyl cyclohexanone. So I think many examples we discuss. We will discuss one example of this containing alkene. See this one example, serial number 6. See this example number 6. This is 1, 2, 3, 4, 5 carbons are there. So it is a pentanone. 1, 2, 3, 4, 5. Yes. On the third carbon, 1 minute, 1, 2, 3. On the third carbon, double bond is there. So the name is 4-methyl on the fourth carbon. On the fourth carbon, methyl group is there. So this is 1, 2, 3, 4. Yes. On the 4 carbon, methyl group is there. 4-methyl pent. Pent indicates total 5 carbons are there. 1, 2, 3, 4, 5. 4-methyl pent. 3 in. This 3 in indicates on the third carbon double bond is there. 1, 2, 3. See the double bond is there. 3 in and 2 on. 2 on indicates on the second carbon carbonyl group is there. So see this on the second carbon. This is carbon number 1. This is carbon number 2. So we can write the IUPAC names of any organic aldehyde or any organic ketone. The common name is mesithyl oxide. Remember the IUPAC names. It is not necessary to remember the common names. Then this is today's homework for you. Today we have to write this homework and send me the scanned copy or snapshots of your assignment by email only. For many examples, I have given the answers also. If you didn't get the answers, just message me. I will give the answers to you. So all these questions are asked for JEE and NEET exam, remember. Then preparation of aldehydes and ketones. These methods already you discussed in the chapter alcohols, phenols, and ethers. Because as the definition of aldehydes is, these are the first oxidizing products of primary alcohols. This reaction is already completed in the chapter alcohols, phenols, and ethers. See the primary alcohols when oxidized with PCC. The name of the oxidizing agent is pyridinium chlorochromate. It is a mild oxidizing agent. If the strong oxidizing agent is used here, first it will oxidize to aldehydes, and aldehydes again get oxidized to the carboxylic acids. So we have to remember one thing here. If you want to stop the reaction at this aldehyde stage, we have to use the mild oxidizing agents like PCC, CrO3. See here, the example is given. What will happen if the strong oxidizing agents are used? See, if the strong oxidizing agent like HNO3, K2Cr2O7, then KMNO4, Na2Cr2O7, these are the strong oxidizing agents are used. First, we will get the aldehyde, and further oxidation, we get the carboxylic acid. See, this is the effect of strong oxidizing agents. So, the strong oxidizing agent should not be used for the preparation of aldehydes. We have to stop the reaction at this stage only, aldehyde stage. So, we have to use this PCC. Then, from the secondary alcohols, we get the ketones. This is a good example of propane 2-ol. This is a secondary alcohol. Oxidation with oxidizing agent K2Cr2O7, or you can use here KMNO4, or you can use here HNO3, any oxidizing agent. We get propanone. This is a propanone, and the common name is acetone. This is very good example. Also, you can use the CrO3, chromium anhydride, we can use as oxidizing agent. So from primary alcohols and secondary alcohols, primary alcohols you can prepare the aldehydes, from the secondary alcohols you can prepare the ketones. Now I am coming to the tertiary alcohols. See, the tertiary alcohols first oxidize to get alkene. Alkenes are prepared when the chromium anhydride is used. This is a tertiary alcohol. CaOH group is bonded to the carbon and the carbon is bonded to another 3 carbon. The name is 2-methyl propane 2-ol. This is IUPAC names. We get 2-methyl propene. Alkene we get first, then again oxidation. We get the ketone. The name of the ketone is propanone, the IUPAC name, and the common name is acetone. Now, the next method is by dehydrogenation of alcohols. This method is used in industrial preparation when the vapors of primary secondary alcohols are passed over heated copper. This reaction is also we discuss in the chapter number 11, that is alcohols, phenols and ethers. This is oxidation by using copper. The ethanol, when the vapors of primary or secondary alcohols are passed over the heated copper at 573. For the primary, secondary and tertiary, the conditions are same. 573, 573, 573. Ethanol on oxidation gives ethanol. Then the second one, propane 2-ol, on oxidation gives propanone. This is a dehydrogenation. H2 molecule is removed, and from the tertiary alcohol we get alkene here. An alkene on hydrolysis we get ketone again. In this example we learned this is a alkene, and after hydrolysis we get ketones. So this question is asked for 3 marks. Remember how the question is asked for board exam. This question is asked for 3 marks. Ethanol to ethanol. How will you prepare ethanol from ethanol? How will you prepare propanone by using propane 2-ol, and how will you prepare 2-methyl propene? Means entire weightage of the chapter is can be asked on one question. Remember, so don't skip any material from this chapter. Whatever the material I have given, that is already skipped, already deleted. Then from the unsaturated hydrocarbons. In 11th standard already you studied the what is meant by unsaturated hydrocarbons, alkenes, alkynes. These are unsaturated hydrocarbons. They contain carbon-carbon double bond. This reaction is already completed in 11th standard ozonide preparation, ozonolysis of alkenes. The propene on ozonolysis they gives a temple-like structure, propene ozonide. Again, they will be this ozonide. It is broken by using the zinc dust and water. We get 2 molecules of aldehydes or 2 molecules of ketone. One is ethanol. These products are depend upon what type of alkene is used here. The product may be changed if the alkene used is different. So this is ozonolysis reaction. Once again, in 11th standard already you studied this reaction. Make a practice at your home. Then by hydration of alkynes. So remember this hydration of alkynes, it is asked for NEET exam many times. 40% H2SO4, see the conditions are important, 40% H2SO4 and 1% HgSO4. Remember this combination. They will give on the arrow like this, ethyne on the arrow, 40% H2SO4 and 1% HgSO4, that is mercuric sulfate, write the product. So this reaction many times asked for board exam, only 1 minute is remaining. Yes, I will complete this reaction. Yes, ethyne on hydrolysis gives first we get the alcohols, and alcohols on tautomerization or isomerization. Isomerization or tautomerization is nothing but only the hydrogen is shifted. So see here, hydrogen is attached to 1 carbon and OH is attached to 1 carbon. We get here alkene and alcohol. Tautomerization or isomerization means this hydrogen is shifted.